Bristol Community College, Mathematics with Susan McCourt. Math 125, Modern College Mathematics. Logic, Section 5, Problem 16. Logic, Section 5, Problem 16, determine whether the argument is valid or invalid. If Mario cooks dinner, then Carla will wash the dishes. Carla does not wash the dishes and Clinton vacuums the bedroom. Therefore, Mario does not cook dinner. We're going to translate that to our logical language of P, Mario cooks dinner. And Q, Carla, whoops, make that dark. Carla washes the dishes. And R, Clinton vacuums the bedroom. And let's see what we got. We have if Mario cooks dinner, so if P, then Carla will wash the dishes, Q. Carla does not wash the dishes, negation Q. And Clinton vacuums the bedroom, R. Therefore, Mario does not cook dinner, not P. So if P, then Q, not Q and R, therefore not P. So we're going to set up a truth table with P, Q, and R. And our statement, if P, then Q, and not Q and R, close brackets, therefore not P. Let's bring down, we have to bring in our truth values, true, 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 false, true, false, true, and true, false, 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 true, true, false, true, false, 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 true, and false, false, false. Okay, let's bring in all of our simple statements or negations. So we have P is true, 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 false, 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 false. Q, true, true, false, false, true, true, false, false. Negation Q, false, false, true, true, false, false, true, true. R, true, false, true, false, true, false, true, false. And lastly, negation P, false, 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 true, 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 true. Okay, so let's look at what order we're going to do this in. This operation's inside the parentheses first, so this one will be 1, the if then. The and here will be 2, and 3 will be the and inside the brackets. And our final one at 4 will be our final if then statement. If P then Q, we have true implies true, true, true implies true, true, true implies false, false, true implies false, false. False implies true, true, false implies true, true, false implies false, true, and false implies false, true. So true, true, false, false, then 4 trues. Not Q and R, false and true is false, false and false is false, true and true is true, true and false is false, false and true is false, false and false is false, true and true is true, True and false is false. So we have 2 falses, a true, 3 falses, a true, then a false. Now our AND statement, bringing together column 1 and column 2, we have true and false, which is false. True and false, false. False and true, false. False and false, false. True and false, false. True and false, false. True and true, true. True and false, false. So all are false except the second from the bottom. Now for our final statement, we're looking at column 3, which I will circle for you, with our not P to look for true implies false, which will give us a false statement. So we have false implies false, which is true. False implies false, true. False implies false, true. False implies false, true. False implies true, true. False implies true, true. True implies true is true. And false implies true is true. So our final column, finally, is all trues, which means we have a valid argument.